Hey, thanks for clicking on my video. Today, we are going to discuss grams versus moles. Now, if you are someone who is a first-time chem student, or maybe you're in college and you are trying to recall things that you learned from high school, maybe you didn't even have chemistry ever. Regardless of the reason why you clicked on this video, I hope that this will help alleviate some of the confusion that you may be facing with this concept. So I've drawn some apples on the bottom. Yes, those are apples. There's one on the left and a few on the right. So below the apple on the left, I wrote 5G, and G indicates grams. When you think about grams, think about mass, and if it helps you any, think about weight as well. When you pick up an apple, right, you know that it has stuff in it. You know that it weighs something. When you pick up a chair, you know that it has mass. You know that mass is being acted on by gravity, just like everything else on Earth. Moles is a different concept. In order to really grasp it, you need to think a little differently than you're thinking about for grams, because moles is not a type of weight or mass. It's actually just a set number. For example, I wrote in the parentheses 6.02 times 10 to the 23rd power, but let's say, for example, 1 mole equals 12. So if you say, hey, buddy, do you want me to go to the store and pick up a mole of apples? That's indicative of saying, hey, do you want me to pick up 12 apples? Think about a dozen eggs. People say things to sort of shorten what they're trying to say. So instead of saying, hey, go get 12 eggs from the store, nobody says that. They say, go get a dozen or go get a half a dozen. So think about it sort of like a way to describe a set number of something that's of interest. The number in the parentheses is Avogadro's number. Again, it's 6.02 times 10 to the 23rd power. So it is a very, 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 very large number. And to think about how large that is, think about moving the decimal to the right 23 times. So it is a very, very, very large number. So just sort of combine the idea of grams and moles, think about the periodic table and think about how you have, yes, the atomic symbol there, but below that, you will see numbers. And those numbers will have decimal points in them. And if you ever wondered what that means, it's the atomic mass. But atomic mass is indicative of how much something weighs, essentially, how many grams per mole a particular element is. So how many grams are in a mole, which is 6.02 times 10 to the 23rd of helium? How many for nitrogen? How many for argon? You kind of see the concept. Grams and moles sort of work together, yet they're so different. And this is an important concept to understand for stoichiometry, which I will be doing a video on eventually. And for a lot of other types of conversions, even simple ones. So this is something you got to grasp if you're going to pass chemistry and move up in STEM. So I hope this video was pretty helpful for you, and I hope that it helped clear some things up, and I will see you in the next video.